Okay, right, question 7, we're doing some integration. We love integration. So part 1, my class did really well on part 1. Show that that integral gives us that value. Well, this is alright, isn't it? This was the integral from 1 to 4 of x to the 3 over 2 minus 1. So we're going to add 1 to the power, x to the 5 over 2, divide by the new power, and then if you integrate 1 you get x between 1 and 4. Now remember, don't put plus c in here. You probably won't lose a mark for doing it, but it shouldn't be there. So you don't put the constant integration in if you're doing it between limits. We now sub the values in. Now this, we're dividing by 5 over 2, so that's the same as multiplying by 2/5, isn't it? So that is 2/5 of 4 to the power of 5 over 2. Take away 4, and we're taking away 2/5 of 1, take away 1. And if we carefully put those numbers through our calculator, it comes out as being 47 over 5, which is 9 2/5. 9 2/5. There we go, as required. And that was a relatively straightforward 4 marks. You tend to find that integration is going to get you quite a lot of marks. Now, hence find the exact area of the shaded region enclosed by the curve, the tangent, and the x-axis. Right. So it's that region there that's been shaded in. Now, if we think about what we have just calculated, we've just calculated the area there. I've exaggerated it slightly so you can see what bit that we've got, but that is the area that we've just worked out. The area between the curve and the x-axis from 1 up to 4. In order to get the area we want, the shaded area, we need to take away from that area this triangle here. That seems sensible, doesn't it? So from our answer to part A, we need to subtract that triangle area. That triangle area depends upon where this line crosses the x-axis. It doesn't cross at 1. It's obviously a little bit more than 1, isn't it? So I need to work out where this straight line crosses the x-axis. What do I know about that straight line? I only know one thing. I know it passes through the point 4, 7. What do I need to know about a straight line? I need to know either 2 points it goes through, and I don't, or I need to know a point that it goes through and a gradient. Well, I do know that it's a tangent to the curve at that point, and I know the equation of the curve. So if I could find the gradient of the curve at that point, that's got me the gradient of the tangent. You see how we've thought this through now? So in order to work out that triangle, I first need to find the equation of the straight line, so I can find where it hits the x-axis. So the straight line has the same gradient as the curve at the point when x equals 4. It's a tangent to the curve y equals, what was the curve? X to the 3 over 2 minus 1. So I'm going to have to differentiate that. And now, last year, I remember this from last year. Last year I had some students, or we had some students come out of the Core 2 exam and say, that question 7, that was impossible. You couldn't do that because the only way you could have done it would have been to differentiate. And differentiate's on Core 1. So you can't do it. Now, we've got to remember that just because something was learnt as part of Core 1 doesn't mean it can't come up in Core 2. Everything connects with what we're doing, especially with the core modules. So anything that you've done in Core 1, you can be asked about in Core 2. You expect to be able to use those techniques. We wouldn't think that we're not going to factorise a quadratic in Core 2, because that was something that we did lots of in Core 1. So the same thing applies to differentiation. We still need to be able to do it. So we're looking when x equals 4. If x equals 4, dy by dx would be 3 over 2 times 4 to the half, which is 2, isn't it? So the gradient of that curve is 3. Fantastic. The straight line has a gradient of 3 and passes through the point 4, 7. So I'm going to use my y minus y1 is mx minus x1 formula. And I'm going to do y minus 7, I'll go straight through it. Y equals 3x, that would be minus 12, plus the 7 will give us negative 5. So y equals 3x minus 5. The reason for doing this was I wanted to find out where my triangle, where the point was in my triangle, where the line hit the x-axis. So when the line hits the x-axis, if y equals 0, I've got 3x minus 5 equals 0, so x is 5/3. So my triangle that I was worried about before, I now know that's the point 4, that's the point 5 over 3, that's the point where y equals 7. And I want to find the area of my triangle. If that's 4 and that's 5 over 3, then that distance there is 4 minus 5 over 3, which is 7/3, isn't it? 4 would be 12/3. Take away 5 gives me 7/3. That height there is 7. It's going from the axis up to 7. So the area of the triangle is a half. Let's do this properly. So area of a triangle is half base times height, so a half the base times the height, which is 49/6 square units. And the question wanted me to find the shaded area. We established right at the start the shaded area was the difference between our answer to part A, to part 1, and that triangle. So the shaded area is my answer to part 1, which was 9 2/5. Take away the area of my triangle, and your calculators are all happy to deal with that and get an answer of 37 over 30. Or 1 7/30. Either one is acceptable. There we go. Square units. Okay? But make sure that you give your answer exactly, because the question said, it did say exact, yeah, find the exact area, so make sure you don't give this as a decimal at the end, find the exact area. There we go. What do we think? It wasn't, mathematically, it wasn't that difficult, was it? It was about kind of unpicking the structure of the question and working out the steps that you had to do. But it was completely unstructured, you know, there was no hint that you had to differentiate in order to get through that, so it was quite useful.
How much do you pay the examiners to give us the marks here?
Right, just off the record, this isn't on the video, although it is on the video, we can't pay the examiners to give us the mark scheme before. Nice try. I won't be there. Nothing will happen. Right, and that's maths.